What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 7, Section 3, the unit circle. Let's do it. So question 1 says to describe the unit circle. So I thought I'd put it up here so I could explain it a little bit better. But in general, the unit circle is called the unit circle is because the radius of the circle is 1 unit. And the way it's usually drawn is it's drawn with the center right at the origin. And it's pretty cool because it's got some great applications to trigonometry. But that's in general what the unit circle is. And you'll see how these different coordinates are used to carry out different trigonometric calculations. So that's pretty much it. Boom, done. So this question says, describe the difference between a coterminal angle and a reference angle. So let's first take an example of this angle. Let's call it around 120 degrees. So let's say here is the angle. This is 120, and there is the initial side and there's the terminal side, okay? So first let's talk about what coterminal angles would be. So coterminal angle would be if we're again starting at 0 and we kind of go around, let's say we pass 120, but we keep going, we complete a circle that's 360, and then we go another 120, which would be at 480. So this blue angle in 480 degrees, because it lands at the exact same spot as 120, this would be considered coterminal. And now we can do this infinitely, right? I can add another 360 and it would be 840, so on and so forth, okay? So that's coterminal. Now when we talk about a reference angle, okay? Now let's go back to that same original angle of 120. What's the reference angle of 120? And a reference angle, a good thing to remember is it's always going to be less than 90, okay? The reference angle is wherever we end up. In this case, 120, we end up here. But it's the same place where we end up with any coterminal angle. We go here and then we say, what's kind of like the shortest angular distance from this angle down to the x-axis? So here we're at 120, the x-axis would be going to 180. So the reference angle here for this 120 is 60 degrees. So that's your reference angle. So starting with an angle of 120, we got a coterminal at 480. We got a reference angle at 60. So that's the gist of it. That's how you do it. Done. So this one says, explain how the sine of an angle in the second quadrant differs from the sine of its reference angle in the unit circle. So we're going to go back to the example from a previous question, which is 120 degrees. So this angle here is 120. Now when we talk about the reference angle, again, if we look at this stopping point, what's the shortest distance to that x-axis? That's going to be 60 degrees. Now when we take sine of 60, you're actually going to get a value that is going to be equal to square root of 3 over 2. And by the way, when you take sine or cosine of an acute angle, you're going to get a positive value. Now, if we go to sine of the original angle, which is 120, okay, what you'll notice is you'll also get positive square root 3 over 2. So in this case, an angle that's ending up in the second quadrant, it's going to give you the same sine value, okay, that you would get for the reference angle of that angle. Now, this is just specific with sine. This will not be the same with cosine, okay, because cosine in the second quadrant is actually going to come out as negative. But for sine, the reference angle and the actual sine value of that angle that falls in the second quadrant, they're going to be the exact same. So that's how you do it. Done. So for this question, I'm going to use a cool little infographic. I think it's really helpful for this. So it's saying, in what quadrant will sine be positive and cosine be positive? Now, this is a quadrant, 4 quadrants, right? You can see 1, 2, 3, 4, and it kind of gives you the cheat codes for like, hey, what's positive where? And when are both of these going to be positive? So the place where everything is positive, sine and cosine, that's going to be in quadrant 1. So the answer to this is quadrant 1. But another quick thing that I want to explain is that what you'll notice is sine is positive everywhere where y values would be positive, right? That's in quadrant 1 and quadrant 2, where we're above the x-axis. So that's where sine is positive. And cosine corresponds to kind of like the x values. The x values are positive in quadrant 1, right, to the right side of the y-axis, as well as quadrant 4, right? Again, cosine will be positive here as well. So that's another way to remember where these values will be positive and negative, but 1 is the answer. Done. So for this one, we're looking at the quadrant where sine is negative and cosine is positive. So the place where I see that sine is negative, cosine is positive, that's quadrant 4. And again, just to reiterate from question 7, you know when this is true because sine is almost like when are the y values on the coordinate plane going to be negative and when are the x values going to be positive. So y's are negative down here and x values are positive over here. So that leads us to quadrant 4. So that's how you do it. Boom, done. So for these questions, we're going to use the unit circle. They're saying, what is sine of pi thirds? And that's an angle in radians. It's also equivalent to 60 degrees, right? So you can see that there, 60 in pi thirds. Now, when we're trying to find sine of pi thirds, we look on the unit circle, we say, here's pi thirds. Sine is the corresponding y value on the unit circle. So the answer to this is simply square root of 3 over 2. By the way, if they were asking for cosine of pi thirds, it'd be the corresponding x value. But square root 3 over 2 is the answer. Done. So for this one, we're going to look at the unit circle at pi thirds, and then to get cosine of pi thirds, it's the corresponding x value, which is 1/2. So 1/2 is the answer. Done. So for this one, we're finding cosine of pi fourths, which again is equivalent to 45 degrees. And cosine corresponds with the x value of this coordinate, which is rad 2 over 2. Now you'll notice the y value would have been the same. So in this case, sine of pi fourths is equal to cosine of pi fourths. But the bottom line is the answer is rad 2 over 2. Boom, done. So for this one, we're finding sine of pi radians is the same as 180 degrees. So again, we go to this coordinate on the unit circle, and we take the y value because that's what sine links up to. So the y value is 0. 0 is the answer. Done. So for this one, we're taking cosine of pi. Here is pi in radians. That's the same as 180 degrees, right? And for cosine, we take the corresponding x value of that coordinate, which is -1. That's how you do it. For this one, we're taking cosine of pi 6, which is right here, same as 30 degrees. Cosine will give us the corresponding x value of that coordinate, which is rad 3 over 2. There you go, done. So for these questions, to give the reference angle, I'm going to use the unit circle just so you can visually identify how to do this, right? And there's a process for this that's a little bit faster, but I really like understanding it. So for example, we're saying 240. Where's 240? It's right here, okay? And we want that reference angle. So here's the full 240 degrees. The reference angle is the shortest distance, which is right here, that acute angle that is from where this ends up to the x-axis. So if this is 240, right, we're going down to 180. So it's 240 minus 180, which is 60. So that's how you get the reference angle, 60 degrees, boom, done. So for this question, to draw at 100 degrees, of course, we're starting with the initial side straight across, and then 90 would be straight up, but it's 100, it's a little more. So we're going like right around here. So let's say there's our 100-degree angle, right? Here's 100 degrees. And then really what we're looking at for the reference angle is the distance, the shortest distance, the acute angle between this endpoint and the x-axis. So obviously this is not acute, so that can't be the reference angle. But what's this remaining piece here when we know that coming back down is 180, it's 180 minus 100, which is 80 degrees. So that's the reference angle. Done. So for this one, 135 degrees would come out here, kind of right to that point, right? And this is just an estimate so you can see what it looks like. And then to get the reference angle, it's this distance or this angle down here going up to 180 degrees. So we're already at 135. We're 45 degrees short of 180. So the answer is 45 degrees for the reference angle. Done. So for this one, we're talking about 2 pi thirds. Now, radians sometimes might be a little trickier. So we imagine, pi going straight across. So 1 pi thirds, 2 pi thirds, 3 pi thirds. We could say 2 pi thirds is roughly here. And now when we look at what would it be coming straight across, right? In degrees, it's 180 degrees, but in radians, it's pi. So here we're at 2/3 pi. Here we're at a full pi. So what's this little difference in here? That's 1/3 pi or pi thirds. So that's the reference angle. Done. Here we're at -11 pi thirds, and we want to get the reference angle. But what I'm going to do is I'm actually going to first find the coterminal angle that's between 0 and 2 pi. It's just going to be easier to draw this out. So if you recall, the way I can do that is I can add multiples of 2 pi. With a denominator of 3 would be 6 pi thirds. So I'm going to keep doing that until we get this positive, okay? So first I add those together, I get -5 pi thirds, but we're still not positive. So let's do it again. And then now we have positive pi thirds, okay? So that's going to be much easier to draw out. So positive pi thirds, we're starting here. And pi thirds, by the way, it's equivalent to 60 degrees. But it's roughly right around here. Now, the thing is, this is already an acute angle, so there's really no reference angle that we even need to calculate. If we know it's between 0 and 90, aka acute, that it is its own reference angle. So pi thirds is the reference angle. Done. Now this one is negative pi eighths, and this is actually already an acute angle. So let's just draw that out because this will become pretty readily apparent what in terms of what the reference angle is. So negative pi halves would be down here, right? It's 90 degrees, but it's coming the other way. So this is less than negative pi halves. This is only negative pi eighths. So let's say it's right around here. This is just an approximation. So here's negative pi eighths. Now, again, the same thing works. It's the distance, that shortest distance, that acute angle back up to the x-axis, which is pi eighths. So you see a reference angle is just going to be positive in this case, but it's going to be pi eighths. That's how you do it. Done. So for this question, we're going to look at the unit circle as we do these calculations. Now, 300 degrees is right here. So the first thing we want to do is get this reference angle, this distance up to the x-axis. So if we're already at 300 and this is like 360, the reference angle is 60 degrees. What quadrant are we in? Well, this is 1, 2, 3, 4, so we're clearly in 4. And now to get sine and cosine of this angle, using the unit circle, sine is just the corresponding y value here, which is negative rad 3 over 2. Cosine is the corresponding x value of this, which is 1/2. That's how you do it. Done. So for this one, we're going to use the unit circle as we do the calculation. Now we have 135, so what's the reference angle? It's going to be this shortest distance down to the x-axis, which if this is at 180, that's 135. The reference is going to be 45 degrees. And what quadrant is this? Well, this is 1, this is 2, so this is in quadrant 2. And now to get the sine and cosine values, sine is the corresponding y value of that coordinate, which is rad 2 over 2. And cosine is the corresponding x value of this coordinate, which is the same, but just negative rad 2 over 2. That's how you do it. Done. So for this one, we got 120 degrees, which lands us right here. So if we start with the reference angle, it's this distance down, that shortest distance to the x-axis, which is 60 degrees, right? 180 minus 120. So the reference angle is 60. And what quadrant is this? If this is 1, this is 2, 3, and 4. This is in 2. And now when we get sine and cosine, we're going to look at this coordinate here. And the sine value of this is the corresponding y value, which is rad 3 over 2. And cosine is this corresponding x value, which is negative 1/2. So that's how you do it. Done. So for this one, we got 150 degrees, which is right here. And so to get that reference angle, it's this distance down to the x-axis, which is 180 minus 150, which is 30. And of course, we're in quadrant not 1, but 2, right? And so now to get sine of 150, we take the corresponding y value, which is 1/2, and cosine is the corresponding x value of that coordinate, which is negative rad 3 over 2. That's how you do it. Done. Now we're dealing with radians. So again, find these radian values on the unit circle. 7 pi 6 is right here. So the reference angle is this distance in here, right? Up to the x-axis. So in degrees, it's of course 30 degrees. You can see that. But in radians, it's this to this, right? So what's the difference between those two? It's pi over 6. And again, pi over 6 is of course equivalent to 30 degrees. So that matches up. And then for the quadrant, we have 1, 2, 3, 4. This is clearly in quadrant 3. Now sine of 7 pi 6 is the corresponding y value of this coordinate, which is negative 1/2. Cosine is the corresponding x value, which is negative rad 3 over 2. That's how you do it. Done. So once again, we're in radians here, and this has radians here as 3 pi 4. So we can see that we're here, and the reference angle is just this distance down to the x-axis. So if we were in degrees, it'd be 135 to 180, which is 45. In radians, it's 3 pi 4ths to technically 4 pi 4ths, which is 1 pi 4th. And when we talk about quadrant, this would be 1, this would be 2, 3, 4. So of course, we're in quadrant 2. So sine of 3 pi 4ths is of course the y value of this coordinate right here, which is rad 2 over 2. And cosine is the corresponding x value, which is negative rad 2 over 2. Boom, done. So for this one, let's find 2 pi thirds on the unit circle, which is right here. And we can see that the reference angle, which is this distance down here, in degrees would be 120 to 180, which would be 60. But here from 2 pi thirds to pi, which is really 3 pi thirds, it's just 1 pi third. And we're talking about the quadrant. We're, of course, in quadrant 2 right here. And when we want to calculate sine and cosine of that angle, we look for sine as the corresponding y value of that coordinate, which is rad 3 over 2. For cosine, it's the corresponding x value, which is negative 1/2. So that's how you do it. Done. So for this one, 7 pi fourths in radians occurs right here. And so the reference angle is this distance up to the x-axis. So since the x-axis is like 2 pi, right, this is 7 pi fourths. The difference is pi fourths. And for the quadrant, since that's 1, 2, 3, and 4, this is landing in 4. Sine of 7 pi fourths is going to be the corresponding y value of this coordinate, which is negative rad 2 over 2. And for cosine, it's the corresponding x value, which is positive rad 2 over 2. That's how you do it. Done. If cosine of t is 2 over 9 and t is in the first quadrant, find sine of t. And by the way, this is not something that's on the unit circle. So we can't use the unit circle. Instead, we're going to create a triangle. So if we create some angle t, cosine of t is adjacent over hypotenuse, which means the adjacent side is 2. The hypotenuse would be 9. And now we're trying to find sine of this same angle. And we can figure out this missing side, which we'll need for sine using Pythagorean's theorem, right? If we call this x, we have 2 squared plus x squared equals 9 squared. This is 4 plus x squared equals 81. Subtract 4 from both sides, x squared equals 77. Take the square root, we get x equals rad 77. Now, we can now take this and find sine using SOHCAHTOA, which says that sine is opposite over hypotenuse. So it's opposite over hypotenuse, which is rad 77 over 9. Now, the last thing we have to consider is it said which quadrant this is in. And this we have to remember because, you know, sine is like the x values. Sine is like the y values, Sine is positive up here and here, right? Quadrants 1 and 2. Quadrants 3 and 4, it's negative. So since this is in quadrant 1, well, everything is positive in 1, including the x values. But anyways, this is going to give you a positive value. That's how you do it. Done. So for this one, they're giving us this value, and it's negative 1/4 is what is sine of t. And by the way, this is not in the unit circle, so we're going to have to use a little right triangle drawing. So let's check this out. We're going to arbitrarily choose t to be here. And it's saying sine is negative 1/4. I'm not really going to pay so much attention to the negative right now, but let's just imagine, you know, sine in SOHCAHTOA, sine is opposite over hypotenuse, right? So that means opposite could be 1, hypotenuse could be 4. And now we're trying to find cosine of t, but in order to do that, again, cosine is adjacent over hypotenuse. So I don't know what the adjacent side is. Let's use Pythagorean's theorem to figure that out. So if this is x, I know that x squared plus 1 squared, which is 1, equals 4 squared, which is 16. X squared equals, subtract both sides by 1 is 15. X equals the square root of 15. So now we have this side. So now when I'm trying to find cosine of t, it's adjacent over hypotenuse. So it's rad 15 over hypotenuse, which is 4. And now it says we're in the third quadrant, okay? 1, 2, 3, 4. So that's what I'm saying, like the negative at the beginning, we don't have to pay that much attention to, because as long as we remember cosine is in the cosine is the x value, and x values are negative in the second and third quadrant, we know that this result has got to be negative, okay? So when I get rad 15 over 4, I know it must be negative. That's how you do it. Done. So this one says find the coordinates of the point on a circle with radius 20 and corresponding angle of 120. So first of all, this would be 90. 120 would be right around here. So normally the radius of a unit circle is 1, but now they're saying the radius is 20. So the nice thing that we can do in terms of figuring this out is we can actually take the original coordinates of the unit circle at 120 degrees, which would be negative 1/2 and rad 3 over 2. And then since, you know, the radius was 1, now it's 20, you basically just multiply both of these by 20, and you'll get negative 10, and then 20 times rad 3 over 2, it's like 20 divided by 2, which is 10 rad 3, and there's your coordinates. Another way to think about this is to figure this out as a triangle, and the reason why this is going to be pretty straightforward is, and you don't even really need trig for this, is you recognize that, you know, this angle in here is 30, right? That's 30 more than 90, which means this bottom angle is 60. This little angle up here is 30. We got a 30, 60, 90 with a radius of 20. So if the radius is 20, that means the little side opposite 30 is half that, which is 10. This side is 10 rad 3, right? It's the little side times rad 3. And since I know that this is a length of 10 rad 3, that y value needs to be positive 10 rad 3. Since this is a length of 10, that x value, but it's going left, right? That x value is going to be negative 10. So we just verified it. That's another way to do it. Done. So this one is kind of interesting. It gives us a radius of 16 and a corresponding angle of 5 pi ninths. The thing is, this is actually not on the unit circle. So let's first estimate where this will go, right? 5 pi ninths, that's a little bit more than 1/2 pi. So 1/2 pi is 90. So we're going to just estimate like it's right around here. Now that we have this, we can construct another triangle like we did in 55. So we got this cool little right triangle, and we know the radius is 16. So that means this is 16, and also this is 16, this length here. And the last thing we know is since this whole angle, meaning this whole angle is 5 pi ninths, this little angle here, aka the reference angle, is the remaining angle going from here down to pi, which would be 4 pi ninths. This right here is enough to use trigonometry to find the coordinates. So now I'm going to show you how, and we're going to have to round, of course. So using SOHCAHTOA, we're going to choose an appropriate function to find either this side or this side. It doesn't really matter. I'm going to start with cosine of this angle, okay? And remembering from SOHCAHTOA, cosine of an angle is equal to the adjacent side over the hypotenuse. So cosine of 4 pi over 9 is going to equal this adjacent side over the hypotenuse. We'll call the adjacent side x. So we'll say it's equal to x over 16, which means that this length here is going to be x equal to, we'll multiply both sides by 16, 16 cosine of 4 pi over 9. And that's pretty cool because that's actually going to give me the x value as long as we negate this, because we're going to the left from 0 by this amount. Now we need to figure out this value, and that's opposite 4 pi ninths. So what's going to use opposite and hypotenuse? That's going to be sine, right? It's opposite over hypotenuse. So now we can also say sine of 4 pi ninths equals opposite, which I'll call this y, over the hypotenuse, which is again 16. So to solve for the y coordinate, we just multiply both sides by 16, and we get 16 sine 4 pi over 9. So we have enough really to get exact values of these coordinates. As I mentioned, this is literally the x coordinate, but negative. So the coordinate would be negative 16 cosine of 4 pi over 9, comma, and then this one, which is 16 of sine 4 pi over 9. But now let's get the approximation in Desmos. So here's the x value, negative 2.778. And then we get the coordinate of the y value, which is 15.75. That's going to round up to 7. So the answer is negative 2.778, comma, 15.757. Boom. Done. State the range of the sine and cosine function. So the cool thing about this is if we actually remember the unit circle just roughly, okay? And if we remember that, you know, sine corresponds with the y values, cosine corresponds with the x values, you can see that the highest the unit circle goes is 0, 1. The lowest it goes is 0, negative 1. So that's our range of sine. And the range is literally, and it's including these values, right? The range is going from negative 1 to 1. So that's sine. And what about cosine? Cosine corresponds to the x values. So the biggest it goes is 1, 0. The smallest it goes is negative 1, 0. So again, we see that the range of cosine is the same. It's from negative 1 to 1. So that's one way to approach it and to think about it. Boom, done. So for this one, we're meant to find sine and cosine of t. And since this is the unit circle, the nice thing about sine of an angle is it corresponds with the y value of that coordinate on the unit circle. And for cosine, it's going to correspond with the x value of that coordinate, which is going to be negative rad 3 over 2. That's how you do it. Done. So for this one, we're taking sine of this angle t. And since it's a unit circle, we're really finding the corresponding y value of that coordinate, which is negative rad 2 over 2. And for cosine, we're taking the corresponding x value, which is also negative rad 2 over 2 for this angle. So that's how you do it. Done. So for this one, we're trying to find sine of t and cosine of t based on this unit circle here, right? So for this one, we're meant to find sine of angle t as well as cosine of angle t drawn in this unit circle here. So the nice thing about a unit circle is sine of an angle is going to correspond with that y value of that coordinate, which is rad 3 over 2. Cosine is going to correspond with the x value of that coordinate, which is negative 1/2. That's how you do it. Done. So for this one, we're trying to find first sine of t based in this unit circle. And the nice thing is that it's simply the corresponding y value of the coordinate that it hits in the unit circle, which is negative rad 2 over 2. And for cosine of t, it's that corresponding x value of the same coordinate, which is rad 2 over 2. Boom, done. For this one, we're first finding sine of angle t and the fact that this is in the unit circle, we just take the corresponding y value of the coordinate, which is for this angle 0. And for cosine of t, we take the corresponding x value of that same coordinate, which is negative 1. Boom, done. So for this one, once again, we're taking sine of t in a unit circle as well as cosine of angle t. And sine is going to be the corresponding y value of the coordinate that it hits, which is going to be negative 0.596. Cosine is going to be the corresponding x value, which is 0.803. Boom, done. So for this one, sine of angle t is going to correspond with the y value of this coordinate, which is 1/2. And cosine of angle t is going to correspond with the x value of this coordinate, which is rad 3/2. Done. So for this one, sine of t is going to correspond with the y value of this coordinate that it hits, which is negative 1/2. And cosine of t is going to be the corresponding x value of that coordinate, which is rad 3/2. Done. So for this one, sine of angle t is going to equal the corresponding y value of that coordinate, which is 0.761, and cosine of t is going to equal that corresponding x value, which is negative 0.649. Boom, done. For this one, sine of angle t is going to equal that corresponding y value of the coordinate, which is 1. Cosine of that same angle is going to equal the corresponding x value of that coordinate, which is 0. Done. For this question, we're going to use a graphing calculator because this is not on the unit circle. So here's the approximation for cosine of 5 pi 9. By the way, just a reminder, make sure when you're using radians that you're in radians mode. So this equals negative 0.1736. Boom, done. So for this one, since it's not in the unit circle, we're going to have to use a calculator to get the approximate value. So cosine of pi tenths is 0.951, and then that would round up to 1 if we're going to the nearest 10,000th. And again, make sure we're in radians mode because we're using radians, not degrees. So our answer is 0.9511. Boom, done. So for this angle, you actually could use the unit circle because it is in the unit circle. And cosine of 3 pi fourths is actually going to be negative rad 2/2. That's the exact answer. But we're going to use a graphing calculator to get the approximation. We'll see it's the same. So here's cosine of 3 pi fourths, and you can see that it's identical to negative rad 2/2. But anyways, here's the decimal approximation, negative 0.7071. So there's your answer. Done. So for this one, we got to plug it into Desmos because this is not in the unit circle. So let's first make sure we're in degrees mode. And then cosine of 98, therefore, is negative 0.1392. So negative 0.1392. Boom, done. So for this value, it's not on the unit circle. So let's plug it into Desmos. And sine of 310, therefore, is negative 0.7660. So negative 0.7660. Boom. So for this question, I'm going to use the unit circle because I can figure out these values. They're all on the unit circle. So sine of 3 pi fourths, which is right here, is that corresponding y value, which is rad 2/2. And then cosine of 5 pi thirds, here is 5 pi thirds. Cosine is the corresponding x value, which is 1/2. So this is going to give me that exact answer. We just multiply them out. We get rad 2 on top. We get 4 on the bottom. That's the answer. So for this one, we got two negative angles, which aren't, of course, on the unit circle, but the coterminal angles will be. So let's get coterminals for both of these. So again, we can add by multiples of 2 pi. That's allowed if we're in radians. So negative 9 pi fourths, 2 pi would be 8 pi fourths. So we're going to add those, and we're still getting a negative pi fourths. That's still not on the unit circle. So let's do it again. Add another 8 pi fourths, and check it out. Now we get 7 pi fourths. That's on the unit circle right there. So this is the same as sine of 7 pi fourths. And then what about negative pi 6? So that's negative. We got to add to it with 2 pi, which is the same as 12 pi over 6. And then we get positive 11 pi over 6, which is right here on the unit circle. So this is coterminal with that. So now we can say, what is sine of 7 pi fourths? That's equal to the corresponding y value here, which is negative rad 2/2. And then what about cosine of 11 pi 6, which is right here? And that's going to be equal to the corresponding x value, right, which is rad 3/2. And now we're going to multiply rad 2 times rad 3 is rad 6. And don't forget that negative over 2 times 2, which is 4. So there's your answer. Done. So for this one, we're going to use the unit circle, but I'm going to recognize right off the bat that's not on the unit circle, but I can find a coterminal angle. So to find a coterminal angle that's on the unit circle, I'm going to add by multiples of 2 pi, but with a denominator of 3, that would be 6 pi over 3. So we add these together and we get positive 4 pi thirds. Now 7 pi fourths, I'm chilling because that's on the unit circle. So this is going to be the same as taking cosine of 4 pi thirds. So what's sine of 7 pi fourths? That's that y value of that coordinate, which is negative rad 2 over 2. What's cosine of 4 pi thirds? It's the corresponding x value of that coordinate, which is negative 1/2. So these two are going to multiply. The negatives are going to cancel out. We get rad 2 times 1, which is rad 2, over 2 times 2, which is 4. Boom, done. So for this one, this angle is not on the unit circle. So I'm going to start by finding a coterminal angle that is on the unit circle by adding multiples of 2 pi. So 2 pi with a denominator of 3 is actually 6 pi over 3. Add those together, we get 5 pi thirds. So we're taking cosine of 5 pi thirds that is on the unit circle, and that's the corresponding x value, which is 1/2. And then we're multiplying it by cosine of pi fourths. Don't have to do anything there because that's on the unit circle. And again, cosine is the corresponding x value, which is rad 2 over 2. And this gives us, when we multiply rad 2 over 4, boom, done. So for this one, first we're going to start with sine of pi. Here is pi on the unit circle. Sine is the corresponding y value, which is 0. And then we're multiplying it by sine of pi 6, which is right here. Sine of this is the corresponding y value, which is 1/2. And 0 times 1/2 is, of course, 0. Boom, done. A child enters a carousel that takes 1 minute to revolve once around. The child enters at point 0, 1, which is in the north position, and then assume it revolves counterclockwise. What are the coordinates of the child after 90 seconds? Okay, so let's imagine this is the origin, and here is point 0, 1, okay? And it's saying that it takes 1 minute? 1 minute to go around, and it's going counterclockwise, and that's 60 seconds. So counterclockwise is going this way. So 60 seconds would be, here would be 30 seconds, right, halfway around, and then here would be 60 seconds, okay? And then they're saying 90 seconds. So we got another 30 seconds remaining. So we're going to go again 30 seconds, which is going to land us right here, right? Another 30 would bring us back to the start point. So they want to know, what is the coordinate at this point? Well, if that's 0, 1, this is going 1 unit down. That's going to be 0, -1. So 0, -1 is the coordinate of the child after 90 seconds. Done. So using the same scenario that we have up here for 103, we know, again, we're starting at point 0, 1, and we've got the fact that we're moving around counterclockwise, and it's taking, 1 minute or 60 seconds to revolve once around. So it says, when will the child have coordinates 0.707, -0.707 if the ride lasts 6 minutes? So first of all, where is this coordinate occurring? Just so we can get a rough idea. So positive 0.707 is like here somewhere, and then negative 0.707 is like here somewhere. And so this is like this. By the way, just as an aside, these values are on the unit circle, okay? These values are rad 2 over 2, negative rad 2 over 2. We're not going to get into where that is on the unit circle just yet, because that will also be another way to hack this solution. But let's just keep that in mind. So we're somewhere here. So now let's imagine as we go around, it's going to hit it multiple times, because as we do one revolution in 60 seconds, aka 1 minute, we're going to hit it once. And then we're going to kind of keep going. And then we're going to do a second revolution, and we're going to hit it twice. So you see, you're going to hit it 6 separate times. Now let's kind of leverage this information that I gave you before, that these are actually values on the unit circle. And this it corresponds with the 45-degree sort of increments, right? So now all of these, little 45 degrees, this is, another 90, this is 135, this is 180. So these are all broken up into 45-degree increments, aka eighths, right? So now we can kind of get a better idea of what's happening here, right? We're going counterclockwise, so this is going 1/8, 2/8, 3/8, 4/8, 5/8. That's when we're hitting this mark of 0.707, -0.707. So it's 5/8 of 1 minute, aka 60 seconds. So 5 times 60 is 300 divided by 8. So that's 150. I'm dividing by 2 3 times. 150, 75, 37.5. So we know it's going to hit at 37.5 seconds. But that's in the first revolution. We're riding for 6 minutes. So that's 6 revolutions. So there's going to be 5 other times where it's going to hit this point. And guess what? This is all going to be coterminal with, if we're adding by 360 degrees, but again, it's also coterminal with 60 seconds. That's the amount of time for one revolution. So to get the remaining pieces, we're just going to add 60 to this up, 5 more times. So we'd also have 97.5. We'd also have 157.5. We'd also have 217.5. Then we have 277.5. And last but not least, 337.5 seconds. So these 6 values are your answers. Done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.